We're not using Flex O2 feedback, so we don't need to worry about that. Ignition timing, we want to set our ignition timing table here. So we'll make this really simple. When we're in boost here from 0 psi and higher, I'm going to do S for set and set this at 0 degrees. When I'm in my vacuum operation here, so vacuum all the way across, so 0 psi and below, all the way across all RPM points. We'll do S for set this at 15 degrees. We've set a really basic spark timing table. By doing this, it allows us to tune our main fuel table without having to worry about knock or pre-ignition occurring. It also allows us to set up our knock control, evaluating really low spark timing when you get into boost here, and we don't have to worry about damaging the motor. So ultimately the name of the game here when we get started, having low spark timing like this will allow us to tune the fuel, then tune the spark. That's always the order of operations we want to move in, and by having low spark timing, it guarantees us not having to worry about damaging the motor. Now we might overboost slightly by having our spark timing relatively low, but that's not so much of a concern right now. I need to map out at least my part throttle fuel first, and then we'll come back in here and revisit this. All right, so now let's move into some of our other tables here. So we have our flex ignition. We're not running any flex ignition. We're not running flex fuel, so we don't need to worry about this. Under ignition trims, we definitely have to go in here and set these up. So looking at our air temp and our coolant temp ignition trim. Looking at our air temp specifically first, we're going to find at the colder air temperatures, I'm not going to offset my ignition timing. These tables are going to be a offset into our main spark timing table. So if our main spark timing table is calculating 30 degrees or showing 30 degrees in the table, these will offset whatever that value is going to be, either adding or subtracting against it. So in the case here of looking at air temperature, we're more concerned at the hotter air temperatures. As our air density goes down, the engine is going to be more prone to knock. What I'm going to do here at an extremely high air temperature, something like 248, I'm going to put a huge ignition retard here against my main spark timing table because I'm very likely to knock or pre-ignite here. So if I do S for set, I'll go here and take out 12 degrees of timing. It'll take that out globally, whether I'm going to be at idle, part throttle, or wide open throttle. We need to reduce the timing down, specifically at more full throttle than we need to be worried about part throttle, but this is again going to be a global modifier. It just goes and offsets our spark timing. I'm going to be starting to be concerned with my air temperature if it gets to 140 degrees, maybe even something like 122, but we'll start here at 140 and we'll go between these two and do H, and we'll do a horizontal interpolation. So as my air temperature gets hotter and hotter, I'm going to be pulling out spark timing at a linear rate to that air temperature ramping up to offset whatever's going on in my main spark timing table to save the motor. Again, this is just for reliability purposes and to avoid knock. Moving into our coolant ignition trim table here. At the colder coolant temperatures, usually below 50 degrees, we need to add some more spark timing in as we fire up the engine cold. That's going to bring back in some idle torque. We lose torque with the poor atomization as the fuel's getting pumped into the engine on a cold motor. We're going to find that the fuel sticks to the intake tracks, the intake valve. It doesn't get into the engine as efficiently. In this situation, we're going to find the engine produces less torque and horsepower than a warm engine. So we need to go and offset that so it stabilizes our idle a little bit. We can use our ignition timing to do that. So jumping into this table here at -40 Fahrenheit in our coolant temperature, I'm going to use S for set. I'm going to say let's add 12 degrees of timing. And then if I get up to about 50 degrees, maybe even 68 degrees here, we'll zero it out. Maybe even 100 degrees is fine. I'm looking at our table here. So we'll go between these two and do H. So once I'm above 100 degrees, it's going to have no more spark timing adder. Our dead band of operation is going to be essentially between 100 to maybe something like, looking at here, maybe 212. So this will be a dead band where it doesn't do anything. It doesn't offset any spark timing. Once it starts to get higher than 212, that's going to be starting to get hot. If we have a hot engine, a hot coolant temperature on our engine, we're likely to knock or pre-ignite. Just as we find as our air density starts to decrease as our temperature picks up, we're going to find that same kind of concern. On a hot engine, it's more likely to knock or pre-ignite because the cooling system isn't cooling the engine properly. So it's going to be inherently heating up the combustion chamber and heating up our combustion process. So we want to offset this with some spark timing reduction. So at 230 degrees here, I'm going to go and take out something like 5 degrees of timing, and then at something like 248, we're going to take out something like 10 degrees of timing. Now, we are going to be putting an overheating protection on this, so if it overheats, it'll hit a rev limiter, and we don't have to worry about damaging the motor, but we'll have multiple fail-safes in place for overheating, so we don't damage the motor and don't have to worry about that. The ignition versus start time, we're not going to do anything with. We can skip. And then the idle versus ignition RPM. This is going to be something we utilize, but in the idle control section, so we can skip this right here. Let's do Control S. Let's go ahead and save that. Let's go into knock tab here. We are going to use the knock control. This does have the factory knock sensor, and we can utilize the per cylinder knock control because it has a coil per cylinder, and it's going to be a direct fire style ignition. So thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss
any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.